stressed. Okay, I'm very happy to be among you guys. My name is Louis, I'm from France, and I'm here to talk about solar sailing and how it may redefine deep space exploration, especially if used with nanosatellites. I don't know if you've ever seen a solar sail, but this is a solar sail. It's like a big kite that is deployed in outer space, and that uses photons and the momentum from photons to push a payload from point A to point B. So when I'm speaking about solar sailing, people ask me if I'm doing solar panels with the company. We're not doing solar panels. We are actually deploying from space a very large and very thin structure that will emit light by reflecting light, and thanks to this reflection, we will push our payloads. So solar sailing is quite interesting since it's a method of spacecraft propulsion that don't need any fuel. It only needs light. So it's, as I was saying, the use of the momentum of photons that enables space exploration. Solar sailing was first theorized at the beginning of the 17th century by Kepler, who was looking at comets. And he understood that in the tail of comets, there were some photons that were being pushed by light. And he theorized that one day, we could actually travel in space with some large ships, and those ships would use light from the sun. Then at the beginning of the 20th century, we had a guy called Konstantin Tsiolkovsky, who was the father of Soviet cosmonautics, who also theorized that we could use solar sails to actually travel in deep space. Everything started to change in the 1980s with the GPL, who looked at the Halley's comets. And GPL asked if maybe we could build a solar sail in order to travel to these comets, to follow these comets, and maybe to take pictures of these comets. Instead of a solar sail, they created the Voyager probes. Then we had, in the 1990s, Russian Znamya, which was an experiment used by, again, Russia. And how could we use light from the sun and use this massive spaceship as some kind of mirror from outer space to reflect light on certain parts of the world. Today, solar sailing is becoming more and more feasible, and a few missions have proved in space that it was actually feasible. The most important one. Okay. The first most important mission was JAXA's Icarus mission in 2010, where the Japanese sent a probe to Venus, and this probe, which was called Akatsuki, then left a small solar sail called Icaros. And this solar sail went to fly by Venus, and it was a mission success. In 2019, we had the Planetary Society, who flew Light Sail 2 in low Earth orbit, to prove that we could actually deploy a solar sail from low Earth orbit. And the operation was to actually prove that a certain type of deployment is feasible, and that type of deployment was the one using booms. Finally, NASA has been working on 3 different solar sail missions for the past years. A first one that flew on Artemis 1, called Neo Scout. Unfortunately, this mission was a failure because the probe did not react well, and I think the probe now is lost. There hasn't been any official statement from GPL nor from NASA, but we know that the spacecraft is lost. A second mission called ACS-3, which will fly soon, and which will again show that the technology used in solar sailing is quite important for future deep space missions. And a third mission called Solar Cruiser. Solar Cruiser's project is to go and monitor flares from the sun. So the company we created in France is called Gamma, and Gamma is working on solar sailing. So I'm going to show you this picture. This picture was taken in France, in Kness, where we were building the first French solar sail. And this first French solar sail flew a few months ago on SpaceX's Transporter 6 mission. We flew a small 6U CubeSat that you will see in the following pictures that is going to deploy an 80 square meters solar sail. So Gamma, as I was saying, is now composed of 20 engineers working just outside of Paris. And our project is to enable deep space low-cost transportation by adding solar cells to nanosatellites. I'm going to show you another pictures. That's when we were integrating the sail. So you can see the sail material is on the table. It's a very thin and very reflective material. It's 2.5 microns. So it's very thin. It's like 50 times thinner than a hair. So it was pretty complicated to integrate it in the satellites. But fortunately for us, we did it. And this is the CubeSat we launched a few months ago. So you can see this is basically where the sail is packed. It's like a hub where the sail, as you can see, the sail material is here, is just around. And the spacecraft is at the moment flying in low Earth orbit. And its only mission is to show that we can deploy a very large structure from space. And this will be a first proof of concept for future missions. And if normally everything goes as planned, we should deploy our solar sail beginning of June or mid-June. So in a few weeks, I hope few months, but few weeks we hope, we will deploy the sail. It's a very interesting technology because it's actually enables new and many different missions. What I think is, so this is those are the first picture we received from the satellite in space. So this is the CubeSat, this is the curvature of the Earth, as you can see. So the sail is still packed in, we have not deployed yet, but we're going to deploy pretty soon. And of course, the goal is to go as far as possible, and this is the mission we want to accomplish in the future. So at the moment, we're working on our next mission that will fly in 2025. It's called Gamma Beta, and it will deploy a 100 square meters solar sail from a 12U CubeSat. And we should soon fly another mission that will maybe go to an asteroid, and we are actually working on this first deep space mission that we hope will fly between 2025 and 2026. I'm not going to enter into details about how solar sailing works and what it actually proposes in terms of opportunities for space exploration. The only point, what I think is important, is that solar sailing is the only type of space propulsion that is propellantless propulsion. We don't need to embark any fuel, which means that we can fly for a long time if the sail comports and behaves well, which also means that we can have new type of mission thought of. So for example, we can fly in certain positions that are unstable by nature, so we can observe the poles of the Earth, or we can observe poles of certain planets. Some people wrote about how we could also, with a solar sail, build what's called a displaced geostationary orbit, which means that basically we would be above or under the geostationary arc, and we could take some pictures and footages from a very particular angle. But what we believe in most at Gamma is just sailing in deep space and enabling low-cost deep space transportation. Our project is to take small CubeSats, 6U to 24Us, equip them with solar sails, launch on cislunar missions, and with the help of all the CLPS missions, we today can find cheap launches to the moon, which was impossible a few years ago. And the idea would be to ride-share on a cislunar trajectory, deploy our sail, and then navigate with the CubeSats with payloads inside to a point, maybe Venus, maybe Mars. We don't really know yet. We are really at the beginning. But the idea is, how can we enable propellantless propulsion? And this is how solar sailing will do it. I'm sorry if I didn't get into much like technical details. I just wanted to give a quick presentation about what we are doing and showing you pictures of what the team has accomplished for the past 2.5 years. And I hope I was clear enough, but if you have any questions, please come and see me. Thank you very much.